welcome to Sevivali Kalvi channel. So today we are going to see about the gate question problems. It is the concept of Johnson counter. This question is repeatedly asking more years in ECE domain gate questions. So the question is a 4-bit Johnson counter with an initial value of 0000. So that means 4-bit Johnson counter initial condition is assigned as a binary value 4 zeros, and the sequence of counting is we have to find what is the counting sequence. So different options have given in this question. We have to find which is the right answer. So we move to solution part. So first we have to consider the logic diagram for this 4-bit Johnson counter. So this Johnson counter can be designed with the help of D flip-flop, because whenever you are giving any kind of input, it may be 0 or 1. That will be the output which is produced by the D flip-flop. So for this reason, the Johnson counter can be designed with the help of D flip-flop instead of JK or SR and T flip-flop. So here the four state of flip-flops have been taken, because 4 bits are given to this logic diagram. So first flip-flop assigned as a variable A, second flip-flop assigned as variable B, third flip-flop assigned as variable C, fourth flip-flop assigned as uh, variable D. So these are the four D flip-flops we have assigned in this example. So the input of this first flip-flop is variable DA, and the second flip-flop DB, third flip-flop DC, fourth flip-flop DD. And the corresponding output for every flip-flops are QA and invert output QA bar, and QB bar, QC bar, QD bar. In case instead of this 4-bit Johnson counter, if you have the question 3-bit means one state of flip-flop can be removed from this given logic diagram. So in this example, 4-bit counter how to design. So because of this condition, we have to take 4 flip-flops. So what is the concept of this Johnson counter is, each and every D flip-flop has a synchronous clock pulse. That means the same clock frequency signal is given to every state of flip-flops. So all flip-flops clock frequency is same, and the each and every output of flip-flop is connected with the input for the next state flip-flop. So simply we can say it is connected in the cascade form. That is, the QA is the output of first flip-flop that is connected with input for second flip-flop, and QB is output for second flip-flop that is connected to input for third flip-flop, and QC is the output of third flip-flop which is connected with the input for fourth flip-flop, and the fourth flip-flop output is assigned as QD. The invert of fourth flip-flop is given as a feedback to the input for first flip-flop. So this is the concept for Johnson counter. So compare with ring counter and Johnson counter, this is the main difference. So when you consider for a ring counter, the last flip-flop output is given as a feedback for first flip-flop input. But in this case, the last flip-flop invert output taken as a feedback input to the first state of the flip-flop. So DA will receive the input from the output of QD bar. So based on this logic diagram connection, we are going to make the truth table. So in this truth table, we have to consider the first column as a clock pulse, and remaining 4 variables are different outputs of the all 4 state of flip-flops QA, QB, QC, QD. And for initial condition, we have to give clock pulses equal to in 0 condition. That means no clock pulses applied to any flip-flop. So at the time, all output of this flip-flop will be 0. So QA 0, QB 0, QC 0, QD 0. And whenever you are going to give the first clock pulse, so first clock pulse to this all the flip-flops. So at the time, what happened? Now you are going to give the input. So that is without giving direct input, the last stage of output is given as an input for first stage of flip-flop. So this is continuously connected like this. So for initial condition, QD output value is equal to 0. The QD is equal to 0 here, and the invert of QD bar is now 1. Now this 1 is given as an input for this DA. So when you give first clock pulse, DA input is received from this QD bar, value is 1. That same value will be the output for QA. So in QA, for first clock pulse, value is equal to 1. Now the previous value of this QA is equal to 0. That moves to the next state, that is the second flip-flop 0. Similarly, the previous state of this QB value is 0. That is moved to QC, and again QC 0 value is moved to QD. Now the one clock pulse is over. Now we are going to give the second clock pulse. In this condition, again your last case QD value is equal to 0. At the time the QD bar value is equal to 1. Now it is again given as an input for this DA. Now the DA values again becomes 1. Now the previous state of DA value is equal to 1. That is moved to DB. So for second clock pulse, in this case, the QA answer is equal to 1. At the same time, QB value also 1. Now the previous value of QB moved to next state QC 0. Again this value is shifted to QD 0. And for third clock pulse is going to apply here. Again this condition becomes 0 in QD. So at the time what happened? The DA will receive the input 1. So for third clock pulse, again QA value is equal to 1. The previous value shifted here 1. And again QB previous value shifted to QC 1. QC previous value shifted to QD. Again the QD value is equal to 0, and the invert of this QD bar becomes 1. It gives to the TA, and in this case the fourth clock pulse is applied here. QA value is equal to 1, QB also 1, QC also 1, QD also 1, because of shifting of one bit of data from one state to another state. So now what happened? This QD value becomes 1. So here the QD value is equal to 1. The invert of this QD bar is equal to 0. Now it is applied to DA. Now for fifth clock pulse, DA value is equal to 0. Because of this, QA equal to 0, and the previous QA is shifted to QB. It is 1. Again QB previous value is shifted to QC. It is 1. And QC value previous value shifted to 1 QD. So now again the QD value is equal to 1. It is inverted into QD bar equal to 0. And again this 0 value is applied here for DA. Now for sixth clock pulse, again QA value 0, QB 0, and QC shifted to 1 because of previous value of QB is equal to 1, and the QD value equal to 1. Now again the QD value is equal to 1 and QD bar becomes 0. This 0 is applied as a input for DA, and for seventh clock pulse the DA value is equal to 0. Because of this QA equal to 0. Previous state DA QA value 0 shifted to QB, and again the previous state QB value shifted to QC 0, and this one again shifted to 1. Now what happened? You just see this 0 0 0 1. The state again, if you give the next clock pulse, it goes to the initial condition 0 0 0 0. So this is the concept for 4-bit Johnson counter logic diagram, and how the clock pulse is given to this logic diagram, and according to this how the different inputs can be shifted from one flip-flop to another flip-flop, and finally what is the exact output we can receive. So from this we are going to find the equivalent decimal value for this 4-bit of binary value. So here for initial clock pulse 0 condition, our output values are 0 0 0 0. So the corresponding equivalent decimal value becomes 0 0. and for second clock pulse 1000 is your output. For this equivalent decimal value is 8. Similarly, for second clock pulse 1100 is the output and the corresponding equivalent decimal value 12. Similarly, 1110 is the binary value, equivalent decimal is 14. Similarly, 411111 is the output, equivalent decimal value is 15. And 0111 is next output for fifth clock pulse and the corresponding binary equivalent is 7. And 0011 output is for sixth clock pulse, the corresponding equivalent decimal value is 3. And for last clock pulse, seventh clock pulse, the output becomes 0001 and the equivalent decimal value is 1. So now you have to arrange all these equivalent decimal values in order. So 0, 8, 12, 14, 15, 7, 3, 1. Again it goes to initial condition 0. So this will be repeated until the clock pulse is given to this circuit continuously. This is the final answer. So from this question, what are the different options have given in the question, we have to analyze properly. After solving this questions, and finally we observed the fourth option 0, 8, 12, 14, 15, 7, 3, 1, 0 is the correct answer for this given question. I think everyone understand this concept clearly. Hope properly understand all those things, how the different counters are properly working and how the shifting operation is taken place, and what are the different kind of counters are there, how the inputs can be given, everything can be remember by everyone properly, then only we can solve any kind of problems easily. Thank you all. Kindly view my channels frequently and subscribe my channel. Thank you all.